All right, if you want to find the length of a curve in parametric, you're going to take basically what we had from before, which is like the speed here. That's kind of like that speed part we had. And then you're going to integrate it from whatever the limits are on your parameter t. So whatever the starting one is to the ending one, if you integrate that, that gives you the length of the curve. Okay, so let's see if we can apply that to a couple problems here. Find the length around the unit circle. We've graphed this one out previously here. If you go on your calculator and have your two x and y parameters be cosine and sine, and graph it, you can see you definitely get a circle there, and the radius is 1, so it is unit circle. So let's see what we get. So we'd want to integrate this from 0 to 2 pi, as you can see here. And we're integrating the speed, so it'd be our dx dt, which our dx dt on this one is going to be negative sine, would be the derivative, squared, plus, now we got to put our dy dt here, which derivative sine is cosine, squared. And dt here. So what are we going to get? Well, negative sine of t times negative sine of t is sine squared. Cosine squared is going to be cosine squared dt. And we're still integrating this from 2 pi to 0. Now, that antiderivative itself is probably very hard to find, or not easy anyway, but we do know sine squared plus cosine squared is equal to 1, so that makes this a lot easier, because this then is just 1. Sine squared plus cosine squared is 1. Square root of 1 is just 1. So what is the antiderivative of 1? Well, that would just be t, evaluated from 2 pi to 0, which means we get 2 pi minus 0, or just 2 pi. So the length around the unit circle is 2 pi. Well, that should make sense. If you remember back, a distance around a circle is also called circumference, and circumference is pi times diameter. Well, diameter of a unit circle, the radius is 1 of a unit circle, which means diameter would be 2. So you got pi times 2, which is 2 pi. So it should make sense that we get 2 pi. Now, most of these are not going to be as easily simplified as the last one. We use a trig identity trick to kind of make that one easier. A lot of these are going to be more calculator based. So what I want you to do first, see if you can pause and set this one up first. So write out the integral. And then what I want you to do is see if you can use your calculator then to evaluate and see what you get. So pause and try it out. All right, let's see how you did on this one. So you got our two derivatives here of dx dt and dy dt. Just using simple power rule here. Put those in. We got square root of dx dt squared plus dy dt squared. I did simplify a little bit here, so 3/2 squared is 9/4. T to the 1/2 squared is going to be just t, and 2 squared, of course, is 4. At this point, I think this is one you could probably keep going and get an exact answer if you did a substitution on this one. But I said let's use calculator on this one, because a lot of these will be a calculator type problem on the exam. So if you put that in using your integral capabilities, it looks like the length of this is going to be about 28.204. So that would be the length of the curve on this one.